We're going to revisit our dice game example and talk about the algebra of random variables. What if we played the dice game twice? What is the mean and standard deviation? What if we played it 10 times? I hope you recognize that playing the game twice is not the same as doubling the score. In symbols, we would say that the random variables work differently than algebra. Adding together x plus x does not equal 2x, and that's because if we have one roll, we might get a 0, and if we have a second roll, we might get a 5, and 0 plus 5 is not the same as doubling each score, okay? The values that we get for doubling the score would only be 0, 10, and 100. The values we get when we just roll the die twice, we could get a significantly larger number of possible outcomes. We could get 0 plus 0, we could get 0 plus 5, we could get 5 plus 0, we could get 5 plus 5. So in other words, we could get 0, 5, 10, 55, 100, or 50. So there's a lot of different values we could get by rolling the dice twice, or the die twice. Also notice that the outcome of 0 on the first roll and 5 on the second roll is different from the outcome of 5 on the first roll and 0 on the second roll. In other words, we have double the probability of this happening. There's only one way to get 5 and 5, but there's two ways to get 0 and 5. Now, remember also that since these events, rolling a dice, are independent events, when we roll the dice twice, we just multiply their probability. So the probability of rolling a 0 and scoring a 0 with our dice roll is 1/2. So the probability of rolling 2 zeros in a row would be 1/2 times 1/2, which is 1/4. In the same way, we calculated all the probabilities of all these different outcomes. It's like 5 and 50 would be 1/3 times 1/6, which is 1/18. To check to make sure we included everything, we then added up all of the probabilities, the 1/4, the 1/6, the 1/6, etc., all the way down, and we did end up with 36 out of 36, or 1. So we do have all of the possible outcomes. Now, since we have some duplicates here, like this is 5 points and this is 5 points, we kind of simplified up here and made a chart here where we said, okay, here are all the things that can happen. We can get a total of 0, 5, 10, 50, 55, or 100, and here are all the possible outcomes. Now, we could do the expected value by doing 0 times 1/4 plus 5 times 1/3 plus 10 times 1/9. We could also put that in our calculator using a one list for the different outcomes and a second list for the probabilities, and do one variable stats. But I want to remind you that when we add two random variables, we can add their expected values. So if we go back to the original game that we played, so let me kind of go back here a few and find that original game. We find in the original game that our expected value was 10 points for one roll of the dice, and the standard deviation was 18.03. So let's go back then and apply that to our new issue here. So we know then the expected value of rolling the dice twice would just be 10 plus 10, which is 20. The standard deviation of rolling the dice twice, since they are independent events, would be the square root, and this I had this with a few more decimal places, the 18.03, so 18.0278 squared plus 18.0278 squared. So the standard deviation would be about 25.5 points using the Pythagorean theorem of statistics. I double-checked this on the calculator, and we got the same thing when we did one variable stats. So let me see if I can find that for you. Okay, so there we got our 20 for our mean, and there's our 25.49 for expected value. Now, what if I wanted to play the game 10 times? Is there a kind of a more efficient way to do it? So let's think about this. We would be adding up from x1 to x10 10 different random variables, or 10 different rolls of the die. So we'd be adding up 10 times. 10 plus 10 plus 10 plus 10. This would be 10 times. So basically it's 10 times 10, which is 100. But realize, once again, that even though we're adding it up 10 times, it's not the same as 10x. Okay? This is not 10, a constant, times x. It's x plus x plus x plus x 10 times. Same thing with standard deviation. We are going to be adding up the standard deviation squared 10 times and then taking the square root. So we can think of it for purposes of calculation is just times 10 under here. And that turns out to have a standard deviation then for 10 rolls of the dice of 57. So our expected total points for 10 rolls of the dice is 100, but we still have a very large amount of variability for that.